So we're going to look at time series. Again, this concept is bivariate So we're going to have time of some sort of set, and we're also going to have another variable in that. So why we call this time series, if you think about it, well, time comes in to explain that the explanatory variable is always time. So whenever you see that time is involved, and in the that's going to be the explanatory variable, and then we can have any other data in the y variable. Usually it comes down to sort of sales. It could be something often to do with that, or share price. It's normally got to do with price most of the time, but it can be anything at all. It could be with weather and looking at time and the amount of rainfall that's occurred, or time and temperature. So we look at the series of that time, and that's why we call it time series. So over the time, what happens? Is there a regular pattern that occurs? And that's what we want to analyze when we're looking at time series. So what are time series plots? Time series plots are just basically we put scatter plot on, and then we join independent lines in there, just like this one here as this example, showing the days, in this case, and sales. So, and then we just join those dots by line segments as well. There are many different types of time series, and we're going to look into those a bit more in depth. Some of those is the seasonal time series, cyclic time series, and a regular time series. And from those, if it doesn't fall into one of those, we also look at the general trend of the graph too. So if it has a general upwards trend going that way, or if it has a general downwards trend coming down that way. So we're going to look at these data, and we look at the time and what happens, basically the data over time, and that's what we talk about. So let's look at the first type of time series would be seasonal fluctuation, or seasonal time series is another word for it. It's one where basically the data fluctuates at regular intervals, usually within a year. So most of the time it is within a year. So we're looking within a year period, and we're looking if it has repeated regularly events. So in this case, you can see the time down here is actually the quarters, so it means quarter of the year, Q1, Q2, Q3, Q4, and we can see that at every, if you look at all the Q3s, see how we hit our peak in each of them. Now there is a steady increase up in the trend line here that we can see, so it goes up, but at the same time we have a seasonal fluctuation happening there, because it does fluctuate that seasons on the Q3 for every time here. So in this case, we can look at houses sold, and we can see that in every third quarter that there's more houses sold. Why would that be the case? Well, if you think about it in quarters, Q1 would be the end of March, Q2 would be the end of June, and Q3 would be the third quarter, which would go from July, August, September. So coming out of winter again, going to spring, people typically actually want to buy houses. And it's probably not the best time to buy a house. If you are looking at actually buying a house, a good time to buy is in the Christmas break or lead up to Christmas, because, well, no one's really got money and everyone's buying gifts. So you get normally a pretty good deal is what I've heard there. Hence, it even shows you in the data that the fourth quarter goes down a bit when people are away on holidays. So you can see there that quarter goes down. So this is where we can use data to influence or see if there is a fluctuation that occurs every time within that year. So if we go to the Australian Bureau of Statistics, which is obviously what we really want to be having a look at in the real world, seasonality, or when we classify things as seasons, doesn't necessarily have to mean it's in quarters. It doesn't have to mean it's in the months. We could even look at a seasonal fluctuation over a week. It doesn't have to be that. So we could look at, for example, if I went to my local Vietnamese store, and they're absolutely busy on a Friday and a Saturday night, so I'd see it peak on Friday and Saturdays. There would be no sales on a Monday because they're closed. So we can see that the fluctuation is consistent there and actually has a season. So it can be over any time period, but within a year. So we can look at the fluctuation over a week. We could look at it over a month. We could look at it over a whole year. But as long as we see that continual regular peaks every time is what we want to look at. So we want to find that consistent peak occurring all the way along the time series. So there are some causes for these. What is the seasonality and what causes that? So there can be natural conditions, which is like weather. So, for example, what's the temperature again, or what's the rain for every month? Obviously, we'd see a peak in Victoria here around winter. it would dry off around in summer. Or we could look at snow. Obviously, we're going to get a lot more in winter than what we are in summer. Business and administrative procedures. So at the start and end of the school term, we could see a peak there in terms of schools getting fees, or we could look at, Officeworks. We could look at their sales. I mean, that would be quite interesting too. Social and cultural behaviors. Christmas is a massive one. We could look at how many people buy turkeys, or we could look at the sales of turkeys or meat go up. We could look at the produce. We could look at the fuel sales. We could look at how much fuel consumption is used. So there's a whole lot of things that can cause this seasonality fluctuations that occur in the data. So that's what we do. So how do we identify seasonality? It's really easy. I like this one. This is actually the monthly retail sales in New South Wales. And over the time, you can see that even though we have the display, so I'm looking down the bottom, yes, it is a time series because this is the year, and we're looking, this is millions of dollars. You can see that there's a peak that occurs within the year, every year at the same time, just near the end of the year. And it always has like this dip afterwards, and then comes back up again in the middle and sort of goes across. So not just these peaks, but also within there's peaks too. Now, I can see there's a slight general increase of trend. Now, even though we're saying slight, we're sort of talking, if I drew a straight line there, about $50 million increase over this time. But you can see a massive peak. Well, hopefully you figured it out. Obviously in New South Wales and being Australia, we like to celebrate Christmas. So the retailers do really rely on Christmas to, basically bring in their profits. I know Sanity, if you ever know that music store, they used to sell CDs. They used to make a loss the whole year except for Christmas, where they used to have bonkers sales. And they would make a profit for the whole year just because they know they can do that. So they'd run down staff and run off the bare bones. From every other month until the run up from November and December in Sanity stores, they would go crazy because everyone wanted to buy the DVDs. Back in the day when I was born, there was no iPods or anything like that, so you couldn't get that. So you'd always see these peaks come up there. So a cyclic time series is another type of series. So we have the seasonal, which occurs within a year. The cyclic, so within a cycle, occurs over that year period. So it's usually longer than a calendar year, and you'll notice the peaks occur more spaced out. So it might occur every second year, it might occur every fourth year, and we're going to look at that. So this is sunspot cycles from all the way back to 1700s all the way to 1990. So again, looking at the scale is really important, because you could say, oh, this is seasonal, but if we actually look at this, we're talking about a 10-year graph in here. I don't really like the way they've done that, because they should be above the dots, so there is a mistake in there. So let's just go with 1749s here, 59s there. So you can see that it peaks about every 10 years. We get some sunspots, and that actually occurs, so we do get a lot warmer weather. So if you can predict from here, 1989, 1999, so 2019 is going to be pretty warm in the summer. That's probably why we had a really hot day just the other day, so it's going to be interesting. So they are very similar, I suppose, to seasonal time series. They do fluctuate up and down. However, not really according to a regular period. So not occurring like on a Sunday every day, or not occurring, at Q3, the peak. So if you look at this example here, you can see that the peaks occur, they're not regular if we look between here. So one occurs, on Q2. So, okay, it occurs now on Q1. So we look at Q1 here, it doesn't quite occur there on Q2. So there's no regular periods between those peaks. Therefore, we call that cyclic fluctuation. So that's a little bit different. So that's a cyclic time series. Unlike a seasonal, where we know it's going to peak at exactly the same times. And that's the difference between those two. The last type of time series is an irregular time series, and what occurs with an irregular time series is it really doesn't have predictable fluctuations, so it doesn't fluctuate up and down a lot. It's more a bit flatter, you would probably say. It may go down, may go up once, but there's no real pattern to it. So you could have cyclical, which has got fluctuations and it comes down, and again, you probably need more information. If you just gave diagrams of time series, just graphs of time series, it'd be really hard to tell the difference between regular and also cyclic time series. However, you should be definitely able to identify seasonal time series. If it wasn't a SAC or an exam, it'd be quite identifiable to see a seasonal. Obviously, we're looking for that same consistent peak and trough all the way throughout.
where irregular and then also looking at cyclical are a bit different. So for example, if I'm a software company and I'll release Pokemon Go, I'm going to have a fluctuation up, which may have been in January, and then I'm going to release another software maybe 6 months later. I'm going to have another peak again in downloads, but then I may not release anything for 2 years, and then after that, I might release the next best thing. Who knows what's that's going to be. So then again, I'm going to have massive sales again. So that will be cyclic because I'm going to have ups and downs. Typically, a regular time series is a bit flatter. So that's normally just, and there's not too much, or there might be one peak, one trough, and that's it. So that's sort of the basics of time series there. Again, any of these time series can actually have trends. So this one here will just say if I fitted a Lin Reg to that, that would have no trend on there, so it'd just be horizontal. We can have a negative trend, but we don't call it negative trend, we call it a downwards trend. So don't get confused with the using the gradient, where the other one will be obviously a positive trend if we're going up this way. No trend, negative trend down this way. Always make sure, 2 questions when you come to a time series. Is it a time series? Look at the x-axis. Is it a measure of somewhat of time? Yes, if it is, we're dealing with time series. Next thing is it seasonal? Does it have regular peaks that occur and troughs? If it does, it is. If it's just got a few peaks randomly, you might say that it's cyclical. If it doesn't really have many, you're probably going to say it's irregular. Again, then we look at the trend too from that, but we can do Lin Reg and we'll talk about more that later. All right, that gives you a good overview. Good luck following this video. There's a few quizzes to test your knowledge.